Now remember something I said in our previous section that you should always start factoring problems by looking to see if there's a greatest common factor to factor out, and then see if you can factor what's left. So looking at our first problem on this page, 2x squared plus 10x minus 28. There's no variables that are in every term, but all of those terms have something even. They're all divisible by 2. So my first step is going to be to factor out a 2 from every term. 2x squared divided by 2 is x squared. 10x divided by 2 is plus 5x. Minus 28 divided by 2 is minus 14. Now that we've factored out the greatest common factor, we're still going to leave that at the front, and we're going to try to take that next parentheses and break it up into two groups. It starts with x squared, so we're going to put an x at the beginning of each one. And now what you want to try to think of is, what can I multiply to get the last number, which is negative 14, that would add up to a positive 5? So 14 could be 1 times 14 or 2 times 7. But since it's a negative, remember we need to put a negative sign somewhere. Putting it on the first row isn't going to help me add up to positive 5 at all. Putting it on the second row, if I wanted to add up to a positive 5, I could do negative 2 and positive 7. That would multiply to be negative 14 and add up to positive 5. That's what I'm looking for. So here, our final answer for factoring would be 2 times x minus 2 times x plus 7. And remember, it would be just as good. The order of the factors is not important. So if you had put instead 2 times x plus 7 times x minus 2, that's just as good. The order of the parentheses makes no difference. Let's try another one. Here we have 3x to the third minus 3x squared minus 18x. So looking at these, there is an x in every term, and there's a number that they're all divisible by. They're all divisible by 3, and the smallest power of x is that last one, x to the first, or just x. So the greatest common factor that I'm going to factor out of each one in this case is 3x. So 3x to the third divided by 3x to the first. The 3's cancel out. X to the third divided by x to the first is x squared. Then we have a minus 3x squared divided by 3x to the first. The 3's cancel out again. X squared divided by x to the first. I subtract the exponents and get x to the first. And then a minus. 18x divided by 3x. The x's cancel out. 18 divided by 3 is 6. So to finish factoring, that greatest common factor stays there, and I'm going to try to split up this next group into two parentheses. It starts with x squared, so I put an x at the beginning of each group. And remember, minus x is the same thing as minus 1x. So here I'm trying to think, what can I multiply to get a negative 6 that would add up to a negative 1? So for 6, you could do 1 times 6 or 2 times 3. Since there's a negative 6, we want to think, where can I put one negative sign to make the pair add up to a negative 1? So you're thinking, if I make this one or this one or this one or this one negative, where could I put the negative sign so the pair would add up to a negative 1, and it would be there in front of the 3. 2 times negative 3 is negative 6. 2 plus negative 3 is negative 1. So here we have 3x times x plus 2 times x minus 3. And that would be your answer. Let's try one more. Here we've got 3x squared minus 12x plus 21. Okay. So looking at these, looking for a greatest common factor, let's see. It looks like they're all divisible by 3. There's not a variable in that last term, so we can't factor out an x. 3 is the only thing we can factor out. So let's divide them all by 3. 3x squared divided by 3 is just x squared. Minus 12x divided by 3 is minus 4x. 21 divided by 3 is positive 7. So if we're thinking of trying to factor this one some more, we'd think, what can we multiply to get a positive 7 that adds up to a negative 4? Well, to multiply to be 7, there's only 1 times 7. Well, that adds up to 8. It doesn't add up to 4. We could make it a negative 8 if we made it a negative 1 and a negative 7, but that's still not what we're looking for. So here, this is an example of one where you can factor out a greatest common factor, but what's left can't be factored anymore. So in this case, factoring out the greatest common factor is the only thing you can do to factor it.